Clear?
Yes, sir.
Yes, sir.
Yeah. So that's how we get the eliminated product, and that eliminated product is alkene, right? So that's what we discussed. And suppose if you have two options to make alkene, suppose if the Br is in the middle, and if you have two options, right? So where will you make the alkene? Which alkene will be the major product? That's what I want to know. Yeah, which alkene is going to be the major product? Which alkene is going to form in the major amount? Main alkene. Yeah, for example, let's do it and then move to the new topic. So all of you can see this. Tell me quickly.
Yes, sir.
Yeah, okay. So suppose if I ask you to do the bromination, photohalogenation. So the first question is, where the bromine is going to get attached? This is the first question. And the second thing I will, so suppose this is A, the major, suppose what is formed, so you need to write the major main product. And then you treat it with alcoholic. Alcoholic means, right, uh, dissolved in alcohol, ethanol, okay, KOH, and heat, base and heat. Is it clear?
Yes, sir.
Yes, sir.
You are going to get the B. So you need to tell me what is the structure of A and B. Very, very important. What are the structure of A and B? Let me show you once again.
Sir, the Br will be attached to the carbon atom which has got more hydrogen, right?
Carbon atom which has got more hydrogen. Actually, bromination, uh, that is not the Markovnikov rule or anything. That is on the alkene. That is different. The one which is shown above. That is addition on alkene. Okay, this is somewhat different. Okay, this is actually your photohalogenation. Okay, photohalogenation in the presence of light. Okay, so in the presence of light, if you take your bromination always occur on tertiary benzylic, tertiary, secondary, and primary. Just write it. This is photohalogenation. This we did long back initially. Imad, you remember? Anushka?
Yes, sir. Now,
Yes,
got it.
sir.
Yeah, actually that hydrogen can be abstracted. Bond energy is lower. So this is the secondary hydrogen. This is tertiary hydrogen. This is primary hydrogen. This is primary, and this is primary. So in photohalogenation, yeah.
So, how do you get benzylic again in the system?
Pardon?
How did you get benzylic that
Yeah, benzylic is this.
reaction?
Yeah. Okay.
Okay.
HNU or UV light or sunlight, it is one and the same thing.
Okay.
So if you do the photohalogenation Br to HNU, what is the structure of A? What is the IUPAC name of A, Anushka? Okay. Is it clear? Anushka, Imad, clear to both of you?
Yes, sir.
Yeah.
This is tertiary. Benzylic is not there. Benzylic is there in the lower question.
Okay.
So this is A. And when you react it with alcoholic KOH in heat, so alcoholic KOH, aqueous KOH do the substitution, alcoholic KOH do the elimination. It removes HX. So Br is there at this carbon, from where the hydrogen is going to get removed. Which alkene you are going to form? You have hydrogen on 3 sites available. Look at this rule, which we studied in the last class. Yeah. So which alkene is formed as a major product? Any idea? So from Br is there. It is only one Br, but from where should I remove the hydrogen? Should I remove from the methyl? Should I remove from the CH2? From where should I remove? Yeah, no,
Methyl, I think, sir?
yeah, from this side actually, you need to remove hydrogen from more branch side. Okay. So this is less branch because it is just one carbon atom, and this is having 2 carbon atom, more branch on the left hand side. This is the ethyl group. Anushka, is it clear?
Yes, sir. Clear.
So what this alkene? So out of all the alkene which is more branched, that is called ZZEV or ZZEF alkene. Okay. This is going to be the major product. Okay. This is. So similarly here also we can replace, this is benzylic hydrogen, very reactive because it is adjacent to benzene, so it can get removed. So you will have PH, CH, Br, CH3. And when you do the alcoholic KOH and heat, elimination will happen pH. So this is the structure. Is it clear?
Yes, sir. Okay.
Okay. Yeah. So let's move on to the next topic, and the next topic is there are identification. Okay, so this can be asked in your school practicals also. Okay. So suppose if you have vinylic halide, and if you have allylic halide, vinylic is the one in which the halogen is connected directly to the doubly bonded carbon. and this is halide. So how you are going to distinguish? Suppose if I give you both the compound in two test tube, you can't see them with your eyes. You can't check the test tube and tell, oh, this is the formula. You can't see the molecule. So which you need laboratory test, you need something to, you will put some reagent and that will react with both of these, and accordingly you will get based on your results, you will judge. Okay, so what you need to put. Okay, so you are going to treat them with, listen very carefully, alcoholic alcoholic AgNO3, and this will be used in many uh, chapters. Okay, and organic chemistry and inorganic also. So be careful about this, right? Okay. So alcoholic AgNO3, what happens is, here the key thing is, here the Cl is not going to come out. Why? Because there is a double bond and the Cl is actually, the electron of the lone pair of the Cl get involved in resonance with the adjacent double bond. And the Cl is more strongly held by the molecule. Okay. So Cl will not come out, right? And the Cl will not come out. But here the Cl can come out very easily. Why, Anushka? Why Cl can come out so easily in allylic and why it can't come out in vinylic? Yeah, in vinylic it is actually the lone pair form of bond with the adjacent doubly bonded carbon, so it is connected by partial double bond character. You can write partial double bond character in this. Is it clear?
Yes, certainly.
Okay, just write it. So it will not come out. Yeah, Ryan, good evening. I hope you can hear my voice. So we are discussing the identification, laboratory identification test of vinylic and allylic halide. We have just started. So vinylic halide, the chlorine is partially bonded to the doubly bonded carbon because of resonance. So it will not come out. And this can come out very easily. Allylic can undergo SN1 also very easily because the Cl is not doubly bonded. Okay. And but how will you know that the Cl can come out and Cl can't come out? Actually, you have taken silver nitrate. Silver nitrate is what? It is equal to Ag plus and NO3 minus. Is it clear? Silver nitrate means what? Ag plus and NO3 minus. And if Cl comes out, if it breaks away from the main molecule, the Cl minus is going to form a precipitate with Ag plus. Okay, so here we are going to get AgCl white. Here we are not going to get the white PPT of AgCl, right? No white PPT of AgCl is obtained. Is it clear? Rayan, Himad, Anushka. But
Clear,
in
sir.
this case,
Yes,
the
sir, clear.
Cl can come out very easily, okay? Because it is not directly connected to doubly bonded carbon. So because it can come out easily, and once the Cl minus comes out and you have Ag plus, both actually form an insoluble precipitate, white precipitate. So here what we will observe, Demath,
Yes, sir.
yeah, white precipitate of AgCl, right?
Yes, yes, sir.
White precipitate of AgCl is formed, right? So always remember the same thing is for chlorobenzene also. Chlorobenzene and benzylic chloride. Which one will give white precipitate with AgNO3? Then where the Cl can come out very easily.
Sir, in the second one, the Cl can come out.
Yeah, in the benzylic chloride. Yeah, this is benzylic. So here it can come out and here it can't come out because it is directly connected to the doubly bonded carbon. So it is overlapping. Okay. So no precipitate of AgCl is obtained. Is it clear?
Yes,
And
sir.
here white precipitate of AgCl is obtained. So, yeah. So let me tell you. So one more question. Suppose if you have you will be asked in your school laboratory also, okay, during the Viva and all, how will you test chloride ion? So have you started your practicals in the school?
Yes, sir, we have.
Yeah, which practical you did?
Sir, we are done with salt analysis, all the salt analysis experiments, and we just started yesterday with flame test.
Yeah, so actually this is there in the salt analysis also, in the test for anions. Okay. So first you put the acid, concentrated acid, you check the gas which is coming out. Okay. So in all of them, whether the Cl is coming out or not, first you need to decide. It is going to come out because it is not the carbon on which it is present is not doubly bonded. Br is also going to come out, and iodine is also going to come out. So how you are going to distinguish them? Okay, so this is going to form, Cl is going to come out, and you are going to form a precipitate of AgCl. This is white, and this is AgBr. What's the color of AgBr? And this is AgI. Light yellow, pale yellow, and this is yellow. Okay, and we will study in coordination compound that these compounds are soluble in ammonia. And this is not soluble. Clear? So chloride, bromide, iodide, take the silver and form the precipitate. Is it clear?
Yes, sir.
Ryan, Imad?
Yes.
Okay. So now we will, yeah. So this is the laboratory test. But if the Cl is connected to doubly bonded carbon, whether it is vinyl or whether it is phenyl, then it is not going to come out. Okay, that is very, very important. Clear?
Yes, sir.
Okay, and now let's do some. There are certain compounds which need to be discussed. Okay, certain important halogen compound need to be discussed. Okay, commercially important compounds. So what are these compounds? So what's the name of these compounds? Tell me quickly. Common name and IUPAC name. Yeah, Imad. First one.
So dichloromethane.
Yeah, dichloromethane. Or or the common name is methylene dichloride. That's the common name. Okay.
So methylene dichloride or methylene chloride?
M- yeah, methylene chloride. Both, because it is common. Methylene dichloride also it is 10 some places. Okay. But methylene actually, methylene means CH2. So it is obvious that there will be two Cl. Okay.
Okay.
Okay. So CH2, Cl2. Methylene means CH2. And the carbon makes four bonds. Okay. So if the carbon make four bond, right? So what else will be connected? Okay. What else will be connected? There will be two Cl. Yeah, Sahil, can you hear my voice?
Yes, sir.
Yeah, so we started with a discussion of some important compounds of alkyl halides, commercially important, which are used in industries.
Okay,
Okay.
sir. Okay, we continue.
Yeah. So these are actually polyhalogen compounds. So this is liquid and it is used as a solvent. What do you mean by solvent? Yeah. What do you mean by solvent? Tell me. In chemical reactions. Yeah.
Dissolve other substances or substances that
Yeah,
will be dissolved.
just for suppose if one reagent is solid, another is liquid, you need to take something for dissolution. Okay. So that is an important solvent, liquid solvent, organic solvent. It is used to carry out many chemical reactions. Okay. So it is a very good solvent and it is mostly used for dissolution of compounds, organic compounds and all, right? So it is other thing is, suppose if you want to remove some wax or paint, it is used as a de-waxing and agent. because wax is also organic compound and it dissolves in it. So most common is it is used as an organic solvent. It is heavier than water. Because of the chlorine atoms. And insoluble in water. Why it is insoluble in water? Anushka, tell me.
Sir, because if it's strong bonds, then it cannot be broken.
Yeah, actually in water, the molecules are joined, they are holding each other by hydrogen bond. Okay, so that bond is stronger, and this is the bond are not that strong, so it is not able to get mixed into water because water is more polar, its hydrogen bonds are more stronger. Okay, and it is not able to break those hydrogen bond. Okay, so that's why it is insoluble in water. Okay, organic compound we have studied like dissolve like. Okay, so water is actually good for dissolution of ionic compounds, NaCl and all, which are plus and minus. But this is a covalent compound, so covalent compound normally organic compound do not dissolve in water. Okay, because they are less polar, right? But we have to be very careful. This is actually, or it can cause irritation to the skin and eyes. So this thing we need to know. It is a very important solvent. Actually, I have in my reactions earlier, I have widely used in lot of large scale pharmaceutical reactions. Okay, and this. And let's move to the next compound, which is CHCl3. Very, very important. What its name is, common name.
Sir, ethylene trichloride. Right?
Yeah, common name. Yeah, there is also common name to it. Yeah, another than this. Sahil, Rayan, Imad. This is
Chloroform.
chloroform. Yeah. If you have CHBr3, that is bromoform.
Bromoform.
And if you have CHI3, that is
Iodo.
iodoform. And collectively, they are known as haloform. Okay. General name is haloform for all of them, right?
Yes.
So where they are used?
Medical.
Yeah, it is chloroform is actually used in widely used in as an anesthetic in earlier times. Medical use for it is used as an anesthetic purpose. Okay, so suppose if you earlier times it was used, yeah. Anesthetic. So what do you mean by anesthetic? Yeah, Anushka.
So it's used as numbing a part of the body. Anesthesia.
Yeah, to make us, it makes us unconscious. So earlier time doctor, before carrying out operation of any part of the body, they used to make their patient unconscious by making them smell chloroform, right? So medical uses chloroform is it is used as an anesthetic, right? Is it clear? All of you will remember. Yeah. So
Yes, sir.
it help us. Vapors of chloroform makes us unconscious. So it is oily liquid. Okay. And there is very important question related to chloroform. Chloroform is stored in dark bottles. Why? In lab.
Can you just repeat the question again?
Why the chloroform is stored in dark bottles? Dark brown colored bottles.
Sir, is it because of the smell?
Now it has some sickly smell, and also let me away from sunlight. So what's the reason? Very important question. Yeah. What could be the reason, Ryan and Sahil?
Uh,
So actually it reacts with the oxygen present in the atmosphere in the presence of, and sunlight gives the energy. And what it forms? What it forms is phosgene. Okay. This is phosgene, right? It is a poisonous gas. Phosgene, if we inhale it, okay, what happens is it gets into the lungs, right? And this is COCl, COCl. In lungs, what happens? It moisture is there in our lungs, so it reacts with the water present in our water vapor present in our body, and it gives CO2 and H2 are not harmful, but HCl. So whatever the, suppose if we inhale phosgene, it will not come out. The HCl will remain inside. It forms HCl in our body. Is it clear?
Yes,
Right? So what happens is it can cause death. It is a very poisonous gas, right? So to avoid this, we do two things. One is Sahil Ryan, that we keep it in dark bottle. Dark bottle will not allow the sunlight to come in, so no reaction will happen. Okay, is it clear,
okay, sir.
Anushka? Right? And the other thing
Yes, sir.
is
Yes, yes.
that we add some drops of ethanol. So this is also a question which is asked: why few drops of ethanol are added to chloroform? So actually, ethanol actually it prevents, it act like a negative catalyst. No, negative catalyst actually is something which stops. Okay. So ethanol it prevents the formation of Anushka. Which poisonous gas?
Sulfazine.
Phosgene. Okay. Another thing is, suppose by chance, if some phosgene forms, then it reacts. Okay. So suppose if phosgene forms by chance, and if you take ethanol, ethanol is C2H5OH. So HCl is removed and it formed diethyl carbonate, which is not harmful. So phosgene was very harmful. And diethyl carbonate formed, which was not very harmful. It was not harmful. Okay. Is it clear? So I
Yes, sir.
hope
Yeah.
this is clear to you. Okay. Yeah. So it is used in many laboratory reagent, many laboratory tests. It is used as a solvent in industry, in pharmaceutical preparation, a lot of chemical reactions. Okay. Chloroform is also used for the production of freons. What are CFCs? Yeah, Ryan, and where they are used? Yeah. So what are chlorofluorocarbons? CFCs are chlorofluorocarbon. So yeah, tell me, Anushka, Rehan, quickly tell me what are chlorofluorocarbons, where they are used. Yeah. So all of you are aware of, yeah, tell me.
Sir, I'm not sure.
Yeah, you can try, no problem. If you know, you can try it, right? Actually, they are used in refrigerant or AC. AC, you know, na, whenever the compressor starts, air conditioner, okay, it circulates a cooling fluid, okay. So that fluid is what? That fluid is what? That is having some carbon Some fluorine are there. Is it clear? Some gas is there in it. Okay. Sometimes you might have also observed, whenever we install a new conditioner, there is a gas which is filled in it. Okay. That gas is actually these are known as freons. Okay. Chlorofluorocarbon. Is it clear? Okay.
Yes, sir. Clear.
Yeah. So refrigerant also we use it. Refrigerator also we see that at the back there is a compressor at the bottom and which circulates this cooling fluid. Imad, Rayan,
Yes, sir.
Sahil, is it clear to all of you?
Yes, sir. Yes, sir.
Okay.
Okay, sir.
Yeah. So this is chlorofluorocarbon, which are used as refrigerant. Okay, but actually there is a risk also of chlorofluorocarbon. Actually, uh, they are causing hole in ozone. They are responsible for the depletion of ozone also. So we need to be very careful that we should not use them in excess. Okay. Now this is iodoform. Iodoform is yellow solid. So very important, yellow solid. So out of these iodoform yellow solid, you can make out very quickly because it is solid and yellow colored. So we can see it very quickly. It's yellow solid and it breaks actually very easily because iodine bond is weaker. Iodine is a very large molecule, so it breaks it and it gives I2. Okay, it also gives yellow PPT with AgNO3. AgNO3, suppose if you use, if I comes out, we get yellow PPT of AgI. Okay, that's the proof. Okay, so iodoform actually gives yellow precipitate of AgI, and if you heat it, it breaks into I2. Okay, so it is a yellow color solid, right? It is insoluble in water because it is carbon compound, and most of the carbon compound are insoluble in water, but it is soluble in organic solvents. In water, they will be insoluble, and because it releases I2, it decomposes as it releases as I2. It is also used as a mild disinfectant, antiseptic. So whenever we get hurt, you might have observed they put some red color liquid, okay, in the first aid. Have you noticed on the wound?
Yes, sir.
So that is actually iodine solution. Okay. So iodoform actually it releases iodine, so it is used as mild antiseptic. Okay, mild antiseptic it is used, and but actually nowadays iodoform is a bad smell, so we use directly iodine. Betadine you might have observed. Betadine is used. Okay, and betadine contain iodine only, right? Now the next thing is your CCl4. What is the name for CCl4? Yeah, tell me. CCl4 is what? Carbon.
Carbon tetrachloride or
Yeah,
carbon?
tetrachloride. It is non-polar solvent. So what do you mean by non-polar solvent? Non-polar, actually carbon and chlorine bond. The chlorine is more non-metallic. It is on the right hand side. So the bonded electron doesn't remain in the middle. They get shifted toward chlorine because chlorine has more tendency to pull the electrons. So chlorine actually acquire minus charge and carbon acquire plus charge. Okay. So this is this because of the difference in atoms and their pulling tendencies. The non-metallic elements which are on the right hand side of the periodic table, they have more strong tendency to pull the electron and they acquire partial negative. This is delta. Okay. Small delta means small amount of negative charge and delta positive. Is it clear? In physics also you might have studied dipole, right? So this bond is actually polar bond. But overall, CCl4 is non-polar. Why, Anushka, Ryan, Sahil, Imad? In spite of having 4 carbon chlorine bond, why the CCl4 is non-polar solvent?
Is it because they're symmetrical?
Yeah, actually this 4 chlorine actually are pulling in all the direction in equal amount. Okay. So they get the actually net pulling of electron get cancelled. Dipole moment actually is a vector quantity. So the net molecule will be polar or not. That depends whether you have the final check you need to do, because there are 4 Cl and they are equally they are all at equal angles. So net resultant it is non-polar. Okay, they cancel each other pulling. Is it clear? Anushka, Ryan, Sahil,
Yes, sir, clear.
Imad. So CCl4 is a non-polar in spite of having CCl bond, which is a polar bond. Someone may ask you, okay, this is a polar bond, right? In spite of having a polar bond, why CCl4 is non-polar? Okay, in spite of having 4 CCl bonds, why it is non-polar? It is because their 4 bonds are in equal directions, equal angle, the net pulling get cancelled. Sahil, is it clear?
Yeah.
So where it is used? It is used as a fire extinguisher.
To cut off carbon dioxide.
Yeah. And it is used in dry cleaning solvent. So all of us must be aware of a dry cleaning. So it is used as a dry cleaning solvent. Industrial solvent, lot of reactions need to be done. But these compounds actually, they are all very harmful for our skin, and also we have to be very careful while we are using them. Okay. So it is a famous dry cleaning solvent, and it is used for the preparation of refrigerant freons. Okay. And it can dissolve a lot of organic compounds. So many organic compound you will see on the arrow CCl4 written, and that is because of the because it is used for dissolution of the organic compounds. Okay, So I hope this is clear. And its commercial name is pyrene. It is known as fire extinguisher. Okay. So let me talk about another very important commercial compound which is used as an insecticide. Can you name insecticide? Some insecticide which is made up of chlorine. Yeah. Any idea? Insecticide which is made up of chlorine. Who is going to tell me? Yeah. Imad, Rayan, Sahil. Insecticide made up of Anushka, chlorine. Any insecticide which is used to kill insect, but nowadays it is banned. It is DDT. Okay. So what's the name of DDT to this? It has been given in your NCRT also.
Sir, is it dichloro?
Yeah, dichloro diphenyl trichloroethane.
Uh,
Right. This is one name, or another name is. So this is actually ethane 111 trichloroethane. Is it clear? And suppose if I remove two hydrogen, Rayan, and if I put two benzene, so two phenyl, and on phenyl also, I put chlorine at the para position. Para means opposite. Is it clear or not? Right?
Yes, sir. Clear.
DDT. So 111 trichloro. Okay. This is for this 111 trichloro. And on two, you have two phenyl rings. Bis also means two. Okay. Parachlorophenyl groups. Okay. On the second position, both are on the second, so two. Okay. Para dash dichlorophenyl. Okay. And trichloroethane. That is the common name. Okay. So it is famously used as an insect. No, you have to remember that structure. It is a famous insecticide. Okay. Clear? How it is prepared? It is prepared by heating chloral and you take 2 mole of 2 mole of chlorobenzene. and H2O is removed, and these two chlorobenzene combine themselves to this double bond breaks, and two benzene join on that carbon, and water is removed. So water removed is possible in the presence of concentrated H2SO4. Concentrated H2SO4 has a tendency to absorb water. Okay. So it absorbs water. So, and this is chloral, and this is chlorobenzene. 1 mole of chloral, 2 mole of chlorobenzene, when heated together in the presence of concentrated H2SO4, which absorbs water, you end up with DDT molecule, which is famously used as an insecticide. It was used as an insecticide. Nowadays, it has been banned. Okay, why it has been banned? Any idea? Anushka, Rehan, Anushka and Rehan, tell me quickly.
So it's because of the chloroform of phenol.
Yeah, it is because of, yeah, actually this is organic molecule, and organic molecule is fat soluble. Okay, so it has two disadvantages. First of all, in 1960s or earlier time, lot of DDT was used, okay, to kill insects, mosquitoes, flies. So what happened was that slowly the insect became immune to DDT. So now DDT became ineffective. And because we are putting DDT everywhere, so whatever the animals which consume the green fodder, they also get the DDT get into their body, and it gets into the fat. And it is non-biodegradable. It doesn't break, and it is fat soluble, so it get accumulated in the food chain. So as you move higher and higher, the higher organism will have more DDT in its fat. Okay, and it has harmful effects. So ultimately, its use is banned. Okay, is it clear? Understood? But you
Yes,
need
sir.
to remember, Sahil, you need to remember why DDT, what's the harmful effect of DDT. Okay, Ryan,
Okay.
yeah, it will be asked that it is non-biodegradable. Okay, it accumulates in the fat, and excessive, because of the large use of DDT, the insect became immune to DDT, and they were not killed by it. So whole purpose of using DDT got affected. So now it has been banned. Soluble in organic solvent or fat, right? So I hope this is clear. Okay. So, and the last one is freon. Okay. So freons are also known as I told you, chlorofluorocarbons. They are used as refrigerant. They are used in aerosols. Okay, refrigerant, and they are used as solvent, right? So you have some chlorine connected, you have some fluorine connected on the carbon, that become chlorofluorocarbon. Suppose if you have CCl4, do you remember how we used to connect, fluorine F? We heated the compound with AgF or COF2 or HgF2 or Sp. SBF5, right? We did long back. So what happens here is some of the fluorine from SB is antimony. Okay. Some of the fluorine from SB comes out. Okay, and they get connected to the carbon, and the carbon actually changes to CCl2F. Okay. Plus, this is Schwarz reaction. This we studied in the beginning of this chapter, so you can go through it it is given in the NCERT also. So this is the chlorofluorocarbon, means carbon has chlorine and fluorine. Okay. And this is freon. The common name is freon, right? So antimony fluoride reacts and it takes away some Cl and gives its own fluorine, and that's how we have your chlorofluorocarbon formed. There are other methods also. You react them with compound containing fluorine, so some of the chlorine gets separated. Okay, so actually you write the number. The number is actually has 3 digits. And this tells us about their commercial name, right? So where they are used, tell me quickly. Sahil, Rayan, Imad. Where do we use freons? Yeah. And what are the harmful effects, Anushka, of using freon? Yeah, Imad, Sahil, Anushka. Yeah, actually, they are used in coolants, the fluid which circulates in refrigerator for cooling or air conditioners. Okay, and they are good solvent. They are used in deodorants, aerosols, wherever you need some pressure and wherever you need some. There are many spray. Okay, you might have seen a spray. So these the qualities actually they get converted to gas very easily, and they develop a pressure. So that's why when we press the deodorant, okay, it comes out with pressure. So this is the common use of these freons. Okay. Harmful effect is harmful effect like DDT is harmful effect. It is responsible for ozone hole depletion of ozone layer, right? So I hope this is clear. Just go through it, go through the NCERT, and though many reactions are very common, and we will be doing it in our next chapter also. So let's start with the next chapter, introduction of the next chapter, and that is alcohol and ethers. Many reactions of alcohol and ether are common with alkyl and aryl halide. Okay. So many reaction we will be using in alcohols also. They are same. Alcohols and phenols, right? And ethers, alcohol, phenols, and ethers. So what do you mean by alcohol? So this is the new chapter, but the concepts are going to be same. So we will be revising a lot of concepts from the last chapter in this chapter. So what is the formula for water? Ryan, it is
H2O.
H2O. Water, oxygen is connected to two hydrogen. Okay. Suppose if you remove one hydrogen and if you put one alkyl group, alkyl group can be methyl, CH3, C2H5 ethyl, propyl, butyl. So what is the common way to write alkyl group? R. That is a general representation of alkyl group. Is it clear? So it becomes alcohol. Suppose if you have one alkyl group, it becomes alcohol. Is it clear? And which alcohol is it? Yeah. This is aliphatic alcohol or aromatic alcohol? Tell me quickly.
Aliphatic.
Sir, aliphatic.
Yeah, aliphatic. Alkyl group is generally represented by R. It can be like in algebra, we represent any number by X. So in organic, we represent any alkyl group by R. So this is aliphatic alcohol. Right? Rayan and Sahil. Suppose if we remove one hydrogen and if we put one benzene, benzene ring can be represented by pH. Short form is pH. Okay. Or you can write, if you want to know, write the formula, you can write it as C6H5. Or if you want to write the structure, you can write it like this. Benzene is C6H6, but if you are connecting it, you need to have one hydrogen less, you free one hydrogen, okay, so that you can connect that to oxygen, okay, from this point. But you don't write this complete structure because it takes a lot of time. So what we do, we don't write carbon and hydrogen, we just draw the lines for the carbon-carbon bond. No need to show carbon hydrogen. So this is all this is same. Is it clear?
Yes, sir.
Okay. So this is, so what it will become? Tell me. If you
So these
remove,
are phenols.
yeah, it will become phenol, PHOH. Is it clear? So we use, where we use phenol in our home? For disinfectant purpose, for cleaning floor and all. Both are same. This is the shortcut. So this is which type of alcohol?
Sir, aromatic.
Aromatic alcohol. Yeah. Phenol, if you suppose, it is also used as a disinfectant, household disinfectant, and while cleaning floor, you can have, it has a peculiar smell, so it has aroma, it is aromatic compound. Okay, it has a benzene ring. Okay, so this is aliphatic alcohol. Is it clear? And
Yes,
suppose
sir.
if we remove the two hydrogen group and we put two alkyl groups, they can be either same or they can be different. Same or different? So what the formula will become? Sahil, Rehan, what the formula of the water will become if you remove cut 2 hydrogen and if you put 2 alkyl group? What the formula? What formula we will get? Clear? Sahil, Rehan, are you getting?
Yes, sir, understood.
So what do we get? Which functional group is this? This is ether. Imad.
Yes, sir.
Yes, sir.
So this is ether. So that's how we get alcohol, phenol, and ether. Okay. We started from water and we remove hydrogen and we put some alkyl group. One alkyl group if we put, so you have ROH, that is an alcohol. If you put alkyl group on both the sides, they can be same or different, that becomes an ether. And if you put benzene on one side and H, so that is phenol. But that is aromatic alcohol. Okay, that is aromatic alcohol. Is it clear? So this is the chapter. This is what we are going to start. So alcohols can be classified into aliphatic alcohol or aromatic alcohol. That is already clear to you. As you guys have seen here, aliphatic and aromatic. So aromatic alcohol have benzene ring. Is it right? In them. So benzene ring, if you have, that is aromatic alcohol. Okay. And if you don't, if you have just one alkyl group and OH, that is aliphatic alcohol. Right? Now the next thing is, suppose alcohols can be, aliphatic alcohol can be classified further. Aliphatic means alkyl group. So what is the IUPAC name of these alcohols?
It's,
Yeah, this one, Sahil.
yeah.
What is the IUPAC name?
It's ROH.
Yeah, ROH is a general way to write. General way. R is methyl in this. Okay. So common name is methyl alcohol or methanol.
Alcohol.
Alcohol, yeah, alcohol is the general name for all these.
Okay.
So it has only one carbon, so methanol. Okay, methanol, right? Meth is the number
Yeah.
of carbon atom. Ane is for single bond, double bond, triple bond, and all is for the function. Is it clear? Methyl alcohol is a common name. Methanol is the IUPAC name. Okay, clear? Right? So
Okay.
Yes, sir.
yeah, Manushka, what is the common name? What is the IUPAC name and the common name for this? Next alcohol. So this is ethyl alcohol, ethane. It is derived from ethane. So ethyl alcohol or ethanol. So this is the IUPAC name. Okay. It means two carbon, and because you have single bond, So eth, ane, actually you remove E because MR you can't put two O's together because all is O, so you remove E and all for alcohol, right?
Yeah.
And what is the name of this alcohol? So
So
ethanol,
propanol.
yeah, yeah. It is primary alcohol or 1 degree.
Yes.
Primary, why primary? Because the OH is connected to carbon, which is connected to one carbon. Okay, that is why it is called primary alcohol. Okay, so this carbon you need to look that because it is connected to one only, it is primary. Now this is propanol. First of all, you need to select the longest chain. Remember, Sahil, Ryan, we discussed longest chain is selected. So it has 3 carbon atoms of prop.
Yeah.
But the longest chain may not be always state. In question, sometimes it is like this. Sometimes you have to move down. You need to check continuous how many carbon atoms are there. So there are 3 carbon atoms. So this is prop, ane, and all. So propanol. Okay. But where the alcohol is, on which carbon it is connected, you need to write the number also. So propane 2 all. 2 means the OH is connected to the second carbon atom. Is it clear? And its common name is isopropyl alcohol.
Okay.
Actually, it was widely used in hand sanitizer during Corona time. Okay, isopropyl. Iso means one is normal propyl. Normal propyl is straight chain, or if you have all the carbon in one after another, and if the group is connected in the middle, so that is iso. If you have one methyl and if the group is connected in the middle, that is called iso. Okay, and what is the structure of propane 1-ol? It is also earlier it was known as 2-propanol. This 2 we used to put that 2 in the starting. That also you will see many places. 2-propanol or propane 2-ol is one and the same thing. So what will be the structure of propane 1-ol? Right? Is it clear? Propane 1-ol.
Yes, sir. Understood.
Anushka, Imar. Okay, propane 2-ol. And this is primary alcohol because on the carbon atom on which the OH is present is connected to one carbon. An isopropyl alcohol, and this is also called normal propanol, N-propanol. Normal chain means the group is at the one end and all carbon are in the straight line. There is no branching. That is called normal chain. Clear? Sahil and Rayan. Okay.
Yeah.
Normal chain. And this is so propane 2-ol was secondary alcohol. Why secondary? Because the carbon on which the OH was present was connected to 2 other carbon atoms, so it was secondary. Similarly, this is tertiary alcohol, 3 degree. You need to look at the carbon atom on which the OH is present. So this is tertiary carbon because it is connected to 3 methyl group. Tertiary alcohol. Okay, 3 degree or tertiary, anything you can write. And the common name is tertiary butanol. Or sometimes it is written at T. But what will be the IUPAC name? IUPAC name will be fixed. It will not change. Okay, it will remain fixed. Just one IUPAC name. So what's the IUPAC name of tertiary butanol? Can you tell me quickly? Anushka, Rayan, Imad, Sahil. You need to select the carbon chain longest. So you can move from this side to this side or this side to this side. It is 3 carbon atom. Continuous. Okay. Sahil, we have seen one example like this in the yesterday's class. So what's going to be the parent chain, the main chain, name of the main chain, that is propane, because there is no double bond. And what all? Because all is starting from O, so I will remove E. But where the all is, where the OH is, Anushka? Is it on the first carbon? Is it on the second carbon? Is it on the third carbon?
Sir, it's on the first carbon.
First carbon or second carbon or third carbon? Where the OH is connected? Look closely.
Second.
You need to do the numbering from end to end. You don't start numbering from the middle. Yeah, the carbon OH is connected in the middle position, so middle is second. So yeah, propane to all. Is it clear?
So how second, sir?
Pardon?
Sir, how second is connected to OH?
Actually, it is like this. I will write it. So you start your numbering from one end to another. 1, 2, 3. Clear?
Yes, sir.
So this is propane to all.
Okay.
This is propane and all is on the second position. But there is one more group at the second position. Which is this group? That is methyl.
Methyl.
Yeah. So 2 methyl propane 2. 2 methyl is the side chain. Okay, propane is the main chain, 3 carbon atom and 2 all, the OH group. Okay, so this is tertiary alcohol. The common name is tertiary butanol, TBOH. Okay, tertiary butyl alcohol. It is written like this. Why tertiary? Because the carbon is connected to 3 carbon atoms, so it is tertiary. Is it clear to all of you?
Yes, sir. Yes.
Priyan, Sahil, Anushka.
Yes,
Yes.
sir. Yes.
Yeah, so we will discuss more IUPAC nomenclature. You can solve the in-text problem of your alcohol chapter. Okay, we will discuss some more questions and we will proceed with the preparation in the next class. Okay, but many of the alkyl halide chapter, alkyl, haloalkane, haloarine questions are going to come up again. So we are going to revise that chapter also. Okay, so let me say good night, goodbye to all of you.